Welcome to new solution video. Here, this is the first question. A metal post is driven vertically down into the ground by dropping this heavy object onto it, and the mass is 120 kg for the object, 40 kg for the post. The object hits the post with a speed of 8 meters per second and remains in contact with it after the impact. Okay, calculate the speed with which the combined post and object move immediately after the impact. So in this question, they have given us the velocity with which the object hits the post. That means from which height it is being dropped is not important. They are in contact, and at the moment the speed of the object, so let's call object 1 as m1 equal to 120 kg, m2 is 40 kg, u1 initial velocity of the object is 8 meter per second downwards. Okay, and u2, the initial velocity of the pole is 0. It is stationary, it is just kept there. Okay, now after the impact they are combined, so we will use the conservation of momentum in this case, and the formula for that is m1 u1 plus m2 u2. That is the total momentum before the impact. After the impact they combine, they means they are one mass and they move together. And question is, what is the speed with which it moves immediately after impact? Obviously it will go down, so we'll get a positive velocity for this, and let's substitute every volume here. So 120 times 8, 40 times 0 equal to 160. 120 plus 40 will be 160 V. Alright, 120 times 8, 960 plus 0 equal to 160 V. So speed V is 960 divided by 160, that is 6 meters per second downwards. B part. There is a constant force resisting the motion. Of course, if it is going into ground, the ground will try to resist the pole, and it is equal to 4,800 newtons. Okay, so resistive force we can say is 4,800 newtons upwards. Okay, calculate the distance the post is driven into the ground. We are talking about the force here, and they're asking about the distance. So what we can do, we can find the deceleration this particular force provides. So we know that MA, which is F net, is equal to the force applied minus resistive force. So mass, both the masses are going down, so 160 is the total mass. Acceleration we are trying to find out. There is no applied force, no external thing that is forcing the pole down, but we know that the weights of both the object and the pole are downwards. So if we draw the free body diagram, we say that 120 kilogram will have 1200 newtons of weight, and then we'll have 400 newtons by the pole. These are the only forces which are continuously being applied on the two objects. There is no external applied force, so we'll count them as applied force because they are in the direction of motion. So 1600 minus 4800 newtons. So 160 A is minus 3200 newtons, and so acceleration becomes minus 3200 over 160, and that is minus 20 meters per second square. This is the deceleration with which it will stop. Now we know the acceleration, and the question is how much distance it goes into the ground. So when the object hit the pole and they became one body, we got that their combined speed was 6 meters per second downwards, right? So that is our u. So u is 6 meters per second downwards, V is 0. After some time, it will go into the ground and stop, right? Acceleration, we just got minus 20 meters per second square. And distance we have to find, so we know that V square equal to U square plus 2 S according to kinematic equations. So 0 square equal to 6 square plus 2 times minus 20 times S. Distance we don't know. So this goes to the left side. It becomes minus 36. 6 square is 36. Minus 40 S. And S will be equal to minus 36 over minus 40. That is 0.9 meters. The pole will go 0.9 meters inside the ground. Let's move on to the next question. A particle of mass 8 kg is suspended in equilibrium by two light inextensible strings which make angles 60 degrees and 45 degrees to the horizontal. So there are two strings with which we have connected or tied up the particle. This particle is of 8 kg, that means its weight will be 80 newtons downwards. The strings are making angles of 60 and 45 degrees respectively. So this is 60 degrees, this is 45 degrees above the horizontal. Yeah, so imaginary horizontal is there. All right, draw a diagram showing the forces acting on the particle. All right, so 80 Newton is its own weight. There will be a tension in this string. Let's call it T2, and let's call this tension as T1. So let's add the components of these forces on this particular particle. So this will be T2 cos 45 degrees. This will be T1 cos 60 degrees. Why cos? Because wherever we have angle with the component, that component is the cos component of the main force, and the angle whatever is there, we add that angle here. So on the opposite side, this is the main force, this is the component cos component, so the opposite side is this one, vertical. This will be T1 sine 60 degrees from here, and from T2 it will be T2 sine 45 degrees. So these are all the forces with components on this object, and that's what they're saying. Draw a diagram showing the forces acting on the particle. These are all forces. When we focus on components, we do not involve the tensions or main forces. Next part is this. Find the tensions in the strings. And in my previous videos of mechanics, you might have seen that we have done these kind of questions many a times. So what is the hint here? The hint here is that they are in equilibrium, right? And we need to find the value of T1 and T2. Because there are three forces and these three forces are in equilibrium, the best way is that we use Lami's theorem in this. What does Lami's theorem says? It says any force, let's start with 80 newtons, divided by the sine of the angle opposite to that force. This is 80 Newton. Opposite angle will be the angle made by the other two forces, which are T1 and T2. So T1, T2. So sine of the opposite angle. So this is 60 degrees, this is 45 degrees, and we know the total this angle will be 180 degrees. So the remaining, if I remove 60 and 45 degrees, 105 degrees from 180, I get 75 degrees left, right? So the angle opposite to 80 Newton is 75 degrees, and sine of that is divided, 80 is divided by the sine of 75. Similarly, T1 is this force, and this is the angle which is opposite to T1. So we will find out this one. This angle is 90. We know this angle is 90 and this is 45. So total 135 degrees angle is opposite to T1. So we will write sine of 135, and T2 will be 90 plus 60, 150 degrees. Sine 150 degrees is the denominator of T2. This is what Lami's theorem is. The force divided by sine of the opposite angles are always equal. This is derived from the sine rule of triangle, and same thing we use here. So look, T1 we want to find, so we can use these two sides, these ones. So let me cross multiply there. T1 will be 80 newtons is here, sine 35 will go and multiply with this, divide by sine 75 degrees. Similarly, I can use T2 with same 80 and sine 75. Sine 150 will go and multiply with 80 newtons. So 80 sine 150 divided by sine 75. One thing I want to make very clear, that Lami's theorem is only for 3 forces, not for 4, not for 2, only 3 forces. And now I have everything here. I will put this in my calculator and I will get the values. By the time I find them, I would like to request you to subscribe to my channel and encourage me to make more such videos for you. And I hope I'm one of the first people in the world to prepare the solution of this paper 43 of mechanics, October-November 2021. And please like and share this video with other friends so that more people get benefited, and obviously I'm motivated. Thank you. And the values I'm getting here is T1 is 58.56, which I will round up to 3 significant figures, 58.6 newtons, and T2 41.41, which will be 41.4 newtons. Alrighty, next question. A ball of mass 1.6 kg is released from rest at a point 5 meters above ground. Okay, so this is the ball and the height is 5 meters. Okay, the mass is 1.6 kg for the ball. When the ball hits the ground, it instantaneously loses 8 joules of kinetic energy. So if 100 joules was the energy, only 92 joules are left because 8 joules are lost in impact. I'm just giving an example, okay? This is not the right number. I'm just giving you an idea. All right. Use an energy method to find the greatest height that the ball reaches after hitting the ground. Potential energy at the start will be mgh. M is 1.6 kg, g is 10, and height is 5 meters. So it will be 16 times 5, 80 joules. Yeah, 50 times 1.6, 80 joules. All right, so now when it reaches in the middle, what is the energy on the ball? The potential energy has reduced, but kinetic energy has increased. When it reaches here, again, the potential energy is 0 now, but all the energy has become kinetic energy. So on the ground, kinetic energy is 80 joules, potential energy is 0, right? Because height is 0 now. Now, they say that on the impact, it loses 8 joules of energy. So after bounce, the energy left is 80 minus 8, which is 72 joules. And they're saying 8 joules of kinetic energy is lost. All of the energy is kinetic energy, so it will be losing only from 80, nowhere else, right? So 72 joules are left and it starts bouncing back. Okay? Now, we have to find what is the greatest height it reaches. So these 72 joules, we will ignore air resistance and everything else, so there will not be any energy loss after this. That means when it goes up, it will not reach 5 meters again. It will reach somewhere less than 5 meters, right? And it will gain a height of h. And at that height, kinetic energy will be 0. Why? Because kinetic energy is half mv square. V stands for speed, and there will not be any speed. At the greatest height, the object stops. So there is no kinetic energy at the greatest height. So at greatest height, Ke, kinetic energy, is 0, but everything becomes potential energy, which will be 72 joules because of the height gained. Alright, so we know this is equal to mg is again 1.6 m, g is 10, height is unknown. So we can find h easily now. 72 divided by 1.6 times 10. So we can use our calculators, and the one I'm getting here is 4.5 meters. So that's the height gained after the impact with the ground. So let's go to the second part. Find the total time taken from the initial release of the ball until it reaches the greatest height again. Alright, so let's divide into two parts. So first, it is falling 5 meters. We'll see how much time it takes to fall 5 meters, and then it gained 4.5 meters height. So let's call that time 1, t1 was taken to fall 5 meters, and t2 was the time taken to reach after the impact with the ground. So let's focus on t1 first. Okay, so initial velocity for t1 is 0, it was just dropped. The acceleration is 10 meters per second downwards. Okay, s is 5 meters it traveled. So we can find time now by this formula, s equal to ut plus half at square. So s is 5 meters, u is 0, and with multiplying with t will make it 0. So half times 10 t square. So this cancels with this 5. Okay, so 5 equal to 5t square, divide both sides by 5. That means t square becomes 1, and if we square root both sides, we'll take the positive time only, t equal to 1 second to drop. Okay, now we have to find t2. Alright, what do we have in t2? We know that final velocity is 0 in this case. Initial velocity we don't know, right? So we can use the same formula but with a different way. In place of ut, we will write vt, and in place of plus, we will write minus half at squared. This is another formula, another version of this same equation. So if we write in place of u, we write v, we subtract the half at squared. So we know it raised height of 4.5 meters, v is 0 again, minus half, and this time the acceleration is downwards because the velocity, it's moving upwards. We have taken 4.5 meter upwards, so acceleration is downwards, so we have to change its sign, t square. So 4.5 equal to this negative and this negative makes positive, it's 5t square again, divide by 5, divide by 5, it cancels here. So t square equal to 0, 4.5 divided by 5, 0.9, and if we square root, t will be about 0.95 seconds, and that makes sense. Okay, so total time taken after the drop will be t1 plus t2, which will be 1 plus 0.95 seconds. It is 1.95 seconds. Let's move on to question number 4, which is this. A car of mass 1400 kg, okay, moves on a straight road against a constant force of 1250. So resistive force is 1250 Newton. The car moves along a horizontal section of the road at a constant speed. So speed is constant, which is 36 meters per second. Calculate the work done against the resisting force during these 8 seconds. So we can say that work done by resistive force or against resistive force is the force itself multiplied by the distance it travels multiplied by the angle the two make. So since it is going this way, the resistance force is this way, so the motion and displacement and force, they have an angle of 180 degree between them. That's why I wrote this. So resistive force given 1250, distance is unknown, we'll keep it for the time being, and the angle of cos 180 is -1, it becomes -1250d. Okay, let's find distance, because the scenario is the constant speed, it is moving with constant speed. So in that case, whenever this acceleration is 0, it is moving with constant speed, we can use the simple formula which we have been learning since our childhood. Distance is speed times time. So speed in this case is 36 meter per second, time is 8 seconds, so that's what d will become. So -1250 times 36 times 8, and that becomes 360,000 joules negative. And since they are concerned with work done only, it's a negative work, yeah, but work is not a vector, we can ignore negative in this case, and this thing, the number we've got, we can write this as 360 kilojoules. Next part, okay, calculate in kilowatt the power developed by the engine of the car. So the power is the force applied by the engine multiplied by the speed of the object. All right. So applied force is not known to us, but we know that there are two facts. First of all, the resistive force is 1250 Newton. And second, the velocity speed is 36 meters per second and it is constant. The constant means that there is no acceleration. We know that ma is applied force minus resistive force, right? Since there is no acceleration, that means the F net is 0. In that case, F applied becomes equal to the resistive force. That's why the difference is 0. So here F applied is same as resistive force 1250, and speed is already known to us, 36 meters per second. We can find the power, which will be 45,000 watts. Or given that this power is suddenly increased by 12 kilowatts. So we had 45 kilowatts, now this is 45 plus 12 equal to 57 kilowatts is power. Okay. Find the instantaneous acceleration of the car. So now the applied force will not be equal to 1250. There will be some acceleration. So again we will use ma equal to applied force minus resistive force. So resistive force remains 1250 because the power belongs to engine. So resistive force of 1250 stays, applied force will change, and we'll use the same formula in this case also. Power, which is 57 kilowatts, is equal to applied force times speed is still 36 meters per second because it is instantaneous. At the same point when it was moving earlier, suddenly it increased. So now we can say that F applied will be 57,000 divided by 36, which will be about 1583.3 newtons. All right. So now we'll use this applied force to find acceleration. Mass is known to us, 1400 kilograms for the object. Applied force now 1583.3 newtons, and resistive force is still 1250. So that was not needed here. So we'll do here a acceleration we have to find out. So 1400 A equal to 333.3 newtons. So acceleration will be 333.3 divided by 1400, which will be almost 0.278 meters per second square. Okay, what about the next part? The car now travels at a constant speed, again constant speed, okay? So we know that there is no acceleration. 32 meters per second, so acceleration is 0. That also means F applied equal to F resistance. That's what we found earlier, right? Whenever speed is constant, that means the forces on both sides are equal. Inclined, road inclined as theta degrees. So let's draw it here. Okay, to the horizontal with the engine working at 60. So power is given 64 kilowatts. Okay, find the value of theta. So we know that F applied, which is in this direction, will be equal to the resistive force. And because this is inclined, we will have one more force. Let me show that force by different color. First of all, the weight of the object is 14,000 newtons, right? So there will be additional force here because of gravity, 14,000 sine theta degrees. There are two resistive forces now. One was already there, air resistance, friction, whatever you said, and there is one more due to gravity. It is going up the hill. That's why there will be additional resistance. So we will make an equation out of this now. So first power equal to F applied times speed. That's what we know. So F applied equal to power over speed. Power is 64,000 watt. That's what is given. Divide by speed is 32 constant. So it comes out to be 2000 newtons. So we'll use our usual relationship MA equal to F applied minus resistive force. Okay, applied we got 2000. Acceleration is 0, so MA will become 0 minus the resistive force FR. We know 1250, and now we will get this one also 14,000 sine theta degrees will be another resistive force. So theta is the only unknown factor here, so everything else is okay. So this becomes how much? 750. Let's bring it to the other side. It will become minus 750 equal to minus 14,000 sine theta degrees. So sine theta equal to minus 750 over minus 14,000. Yeah, those cancel out. So that gives us theta equal to sine inverse of 750 divided by 14,000. And let me find this angle by putting in my calculator. And by the time I do this, I request you to subscribe to my channel, like and share this video with your friends so that more people get benefited out of it. And I'm motivated to make more videos like this for you. And when I use my calculator, I got 3.07 degrees. We can make it, yeah, that is 3 significant figures. Yeah, 3.07 degrees. Question 5. A particle P moves in a straight line starting from a point O, okay, on the line. At time t seconds after leaving O, the acceleration of P is k 16 minus t square. So this is a very important sentence, starting from rest. That means when t is 0 at this point, it is starting. V is also 0, and obviously displacement is also 0 because it is on the point. So displacement from O is 0. These facts will help us in later stages of the question. The displacement from O is s meters. The velocity of P is 8 when t is 4. This will also help us show that the displacement is this. Displacement equation is this. We have acceleration equation. So from acceleration equation, we need to get velocity equation first, then only we can go to displacement, and we'll integrate this whole thing with respect to time to get a velocity equation first. So let's do it. So integration of acceleration is velocity. K is a constant, so we'll keep it out. We'll just integrate 16 first. So 16t minus this one will be t 2 plus 1, 3 over 2 plus 1, 3, and plus c. So we need to evaluate c before we get the value of k. So to evaluate c, this will help. When t is 0, v is 0. So we'll substitute t and v in this equation and we'll get our c. So 0 equal to k, 16 times 0 will be 0, minus 0 cube over 3, 0, plus c. That means c is 0. So your equation for velocity becomes k 16t minus t cube over 3. That's it. No c anymore. Now we were on the way to find the equation for displacement. So let's integrate this again to get displacement. All right. So let me integrate this one. So it will be again integrated with respect to time, and we will again integrate k 16t minus t cube over 3 dt. All right. So the integration of velocity gives us displacement straight away, and since k is again a constant, so we should evaluate k first. So let's evaluate k. We knew one more situation, remember? When t was 4, v is 8. So we can do here, v is 8 when t is 4. So let's put 4 here, minus 4 cube over 3. So 8 equal to 64 minus 4 cube is also 64 over 3. Okay, so 8 equal to 64 times 3, 192. Okay, let me do it here, 192. I'm doing it mentally. Please use calculators if you are not understanding what is happening here. So it is coming out to be how much? Let's see. 8 times 3. Let's cross multiply this. Equal to 192 times minus 64 will be 128 and k. And that gives us k equal to 24 over 128. Okay, we can cancel this also. 24 divided by 8 is 3. 128 divided by 8 is 1 and 6. 3 over 16. So we were talking about k. So k is 3 over 16 now. Keep it out. Just integrate 16t. 16t square over 2 minus, this will become now t 3 plus 1, 4 divided by 4, and there was already a 3 down there, so we'll multiply that 3 with the denominator and plus c. Now we have to evaluate c before we proceed and simplify it with the target. What is our target? 1 over 64. This is our target. So we'll use this. When t is 0, s is 0, and that will give us the value of c. So 0 equal to 3 over 16. So 0 square will be 0. So this is also 0. This is also 0. Oh, nothing left. So this is also gone. Everything gone. Everything is c. So c is 0. So the final equation we get 3 over 16 s equal to, let me change the color so that is clean available to us. S equal to, this s equal to, we have 3 over 16. 3 over 16. Now we can see here this is 2, this is 12. So let's take 2 out common. So 2 comes out. This is t square, this is t to the power 4. T square can also come out. All right, what is left inside? 2 is out, t square is out, 16 is left here. Minus t4, okay, out of t4, t square is out. So t square is left. 4 times 3 is 12. Out of 12, 2 is out. So 6 is left. And I don't think it is matching with what they want. Is it matching? Okay, they removed this 6 also. So let's remove this 6. And how do we remove this? Let's multiply this by 6 and divide by 6. Why did I multiply here and divide here? Because this 6 I'm multiplying with the bracket, and this 6 will multiply with outside, whatever it is. So 3 and 6 cancel out. So what do we left? T square only on top. Okay. Over 2 times 2, 4, 4 times 16, 64. Alright, now this 6 will multiply with 16, 96. Minus, when this 6 multiplies with t square over 6, 6 and 6 will cancel. That's why I chose 6. So it will be just t square left, and I think this is the one they wanted to arrive at. Let's see. Exactly. So let's go to the B part. Find the speed of P at the instant when it returns to, okay, when displacement is 0 again. Returns to O means it is back at O and displacement is again 0. And now we have an equation for displacement. We'll make it E equal to 0. S equal to T over 64, 96 minus T square, right? It is equal to 0. Since these two parts are factored, so we can straight away write either T square over 64 equal to 0 or 96 minus T square equal to 0. So it cross multiplies, becomes 0. So T square equal to 0, square root both sides, T equal to 0. We already knew that displacement is 0 when T is 0. So this is not a news. It is okay. This is what will give us a new answer. So 96 minus T square equal to 0. So 96 equal to T square, square root both sides. We can't have a negative time, so square root 96 is the time. And since they're not asking the time, so let's keep it exact form only. Square root 96 seconds is the second time when it went away from O and returned back. So it was 0 when it went, turned back sometime later and returned to this again when T was square root 96. Now they're asking speed at that time. What is the speed? So we have speed equation earlier. So let's see what was the speed equation. It was here. This was speed equation, right? So V equal to K was 3 over 16. Yeah, 16T minus T over 3. So V equal to 3 over 16, 16T minus T cube over 3. So V when, when T is square root 96 will be 3 over 16, 16 square root 96 minus square root 96 cube over 3. So in place of T, I just put square root 96. Let's put this whole thing in our calculator and we'll get the velocity, the speed at the time when it returns to O. By the time I do this, I would like to request you to subscribe to my channel and share and like this video, share with your friends, get them the benefit of detailed solutions, and this will also motivate me to make more such videos for you in future. Thank you. And when I put this in my calculator, I got 29.4 meters per second. Let's move on to the next part, which is this. Find the maximum displacement of the particle from O. So if you remember, we do like this. At t equal to 0, it was here, displacement was 0. Then it came back at t equal to square root 96 is returned here. They're asking what was the maximum displacement when it turned back. So when it turns back, the velocity becomes 0 again. It started from rest. Here also v will be 0. So we will equate the velocity equation E equal to 0 and we'll get the time when it turned back. So what was the velocity equation? It was 3 over 16, 16t minus t cube over 3. Let's make it equal to 0. So 3 over 16 cannot be 0. So that is ignored. Just this bracket part will be giving us the time. So let me write it here. 16t minus t cube over 3 equal to 0. 16t stays there. T cube over 3 goes to the other side. And now we can cross multiply and collect t's on the one side. So let's bring this t to the right side. So it becomes t cube over t equal to 3 goes and multiplies with 16, 48. So t goes and cancels with this, we'll be left with t square only. And if we right, this will be t square equal to 48. Square root both sides. Square root 48 is the time. And we'll substitute this now. They're saying what is the maximum displacement. So in the displacement equation, we will just substitute t equal to square root 48 and we'll get the maximum displacement. So the equation was this, t square over 64 rather. Okay. T square over 64, 96 minus t square. This was the equation. So when t is square root 48, what will be the s? So square root 48 square over 64, and then 96 minus square root 48 square again. So square and square root cancel here, square and square root also cancel here. So 48 over 64 will be 16 times 3 is 48, 16 times 4 is 64, they cancel out. Equal to 90, sorry, not equal to, 96 minus complete 48. So it comes out to 3 over 4, 96 minus 48 will be 48, 4 and 48 cancel. 12 times 3, 36 meters is the maximum displacement we got. Let's go on. And this is question number 6. Here they're saying the diagram shows a particle of 5 kg here, 4 kg hanging on the left side, 6 kg hanging on the right side. Particle masses are this. Okay, they're explaining the same thing. Particles of 6 kg is 0.5 meter above. Yeah, they've shown here. The system is in limiting equilibrium, means it's not moving. All right. Show that the coefficient of friction between the 5 kg particle and the surface here is 0.4. So limiting equilibrium means all the forces on this 5 kg are balanced out. So let's see what are the forces on this. So in this way, because of the weight of this 6 kg, the force will be 60 newtons. Right? This way, the force will be 40 newtons. And because 60 Newton is more than 40 Newtons, this system should move this way. But it is not moving. That there is a frictional force in this direction, which is mu r, which is adding to 40 Newtons, so that 60 Newton is balanced out. That becomes our equation. And that will give us the coefficient of friction. For that, we need r. And r, because this is not resting on the surface, its own weight is 50 newtons, so the reaction force upwards, normal contact force, will be 50 newtons only. So we'll just use these information and we'll get our hopefully coefficient of friction will be 0.4. All right. So 60 newtons is equal to 40 newtons plus mu, and r is 50 newtons. So let's bring 40 to the other side. 60 minus 40 equals to mu times 50. And this can complete here. 20 equal to mu times 50. And mu stays here. It becomes 20 over 50. And yes, 20 over 50 is 0.4. Let's see what is the second part. The 6 kg particle now is replaced by a particle of 8 kg. Now it will not be in limiting equilibrium. The system is released from rest. Find the acceleration of 4 kg particle and the tensions in the strings. Okay. They're asking the acceleration of 4 kg particle. Does that make sense? Because the whole system will move. That means the acceleration of 8 kg, this is 8 kg now, 8 kg, 5 kg and 4 kg, all of them will have same acceleration, but they are asking only 4 kg. So there's no need to worry about it. Let's focus on, so the new system becomes, in place of 60, it will be 80 kg. We'll use this one now. F net is equal to mass times acceleration applied force minus resistive force. So 80 Newton is the applied force minus resistive forces are 40 Newton, and then mu and 50. Mu is 0.4 now and 50 is 50. This will be equal to mass times acceleration. Mass, because all three masses are moving, so we will add all of them. 4 plus 5 plus 8, all three masses times acceleration. So 80 minus 40 is 40, minus 0.4 times 20 will be 20, equal to 9 plus 8, 17a. So it becomes 20 equal to 17a. A will be 20 over 17, and that will be 1.176. So let's write 18. Okay, meters per second square. That's the acceleration of particle of 4 kg. Now they're asking the tension in the strings. So whatever is the tension in this one, let's call it T1, will be the tension here, but it will be having a different tension because they are not connected directly, they are connected through this particle. So let's call this one T2. So to find T1, let's focus on only this area. So 4 kg, let me draw its free body diagram here. So T1 is the tension upwards and it is moving upwards only, and 40 Newton is the weight of the 4 kg particle, and let's write the same equation, MA equal to applied minus FR, resistive force. So MA, mass is 4 kg, because we are focusing only on 4 kg this time. Acceleration we just got 1.176, let me write 1.176 so that I get closer answer, equal to applied force because it is moving up. So T1 becomes applied force, T1 minus 40 becomes resistive force. So T1 stays to the right side, 40 goes there. 4 times 1.176 plus 40 will be the tension. It comes out to be 44.7 newtons. But in question, they are talking about the tensions in the strings. That means second tension is also to be found out. And for that, we'll focus on the 8 kg mass, which is on the right side. This one, which is 6 kg, which is 8 kg now. So we will focus on this point. Let's draw a free body diagram for this. So the downward force will be 80 newtons, the weight of the particle, and then will be tension upwards. So now our formula is mass times acceleration is applied force minus resistive force. Mass of this particle is 8 because we are focusing only on this. Acceleration we got was 1.176. Applied force, because the system is moving down this time, so 80 Newton becomes the applied force, and tension T2 becomes the resistive force. So we'll bring T2 to the left side, it becomes positive T2 equal to 80 minus 8 times 8, so it was 1.176, which is 70.6 newtons. Alright, is there any other part? Yes. In subsequent motion, the 8 kg particle hits the ground. So 8 kg particle was 0.5 meters above ground, so it hits the ground and stays there, okay, and does not rebound. This sentence they have written because otherwise people will think that when it goes up it will come down again and again it will pull the system downwards. So no, it does not rebound. Find the time that elapses after 8 kg particle hits the ground before the other two particles come to instantaneous rest. So you may assume this occurs before either particle reaches the pulley. Alright, so let's go back to the picture and try to visualize what they're trying to say. Okay, so this is the system. In this system, when this 8 kg, this is 8 kg right now, when it reaches ground, this 4 kg will go up by 0.5, right? This 5 kg will go to the right by 0.5 and then it hits the ground. Why did they move by 0.5 meters? Because this 8 kg mass, 80 newtons of force downwards, was pulling it. But once this hits the ground, there is no more force that hits, that pulls it to the right side. So both of them will move for some more distance after 0.5, but that will be based on inertia. They had a momentum going towards the right, that's why they will continue. But because there is no applied force after that, they will decelerate and stop somewhere, and that's what they're saying. How much time after this it hits the ground, how much time is taken by these two masses to stop, come to instantaneous rest? All right. So whenever you have such a situation, just find what was the velocity here at this point when it hit the ground. Okay. So we know that the whole system moved 0.5 meters, and the acceleration we found was how much? 1.18 meters per second square. We'll use this fact now. Okay. So because it started from rest, so u is 0 meters per second. Acceleration is 1.18 meter per second square, and distance they moved was 0.5 meters. So we can use v square equal to u square plus 2as. This is the kinematic formula which we can use. And v square we want to know, u we know it was 0, 2 times 1.18 times 0.5. 0.5 and 2 become 1, so v square is 1.18, and square root both sides, we'll get 1.085 meters per second. So now we know the initial speed of the stage when the particles started decelerating. So let's assume that this was the point of that 5 kg mass was here, and here the initial velocity now becomes 1.085 meters per second. It has to travel some distance and v will be 0. So we know the formula v equal to u plus at. We have v, we have u. If we somehow find acceleration now, we'll find time. That's what they're asking. So to find acceleration, we'll have to go back to our free body diagram. Let's say what was the force that was pulling it. The force is 0 newtons now, because the 80 newton which was dragging it has hit the ground. There is no force that is pulling it, but there are two forces still trying to stop it. One was 40 newton, the weight of the third particle, and the friction. Friction was 50 times 0.4, 0.4 was the mu, right? So 20 newtons. 40 plus 20, this 60 newton is still resisting it. Okay, that will give us the acceleration now. So we'll go back to our equation. Ma equal to force applied minus resistive force. Mass, now only two of the masses are moving. 8 kg mass is on ground. So 5 plus 4, 9 kg times acceleration. Applied force is 0, but resistive force is 60 newton. So acceleration comes out to be minus 60 over 9. Let's simplify this. So minus 20 over 3 meters per second is the acceleration. Now we know u, we know v, we know a, we can find time. All right, let's do it. So v is 0, it stopped finally. U, it was moving at the starting, 1.085 plus the other, okay, we'll write here, minus 20 over 3 is the acceleration, and time we want to find out. So 1.085 goes to the left side, 1.085 equal to minus 20 over 3t, and let's finalize it here. Time will be minus 1.085 times 3 over negative. So negative and negative cancel out, and time, when we put this whole thing in our calculator, we get 0.163 seconds.